Okay, this is video number 2 for the midterm review for CP Algebra 1. Make sure you have reviewed the packet number 1 video. If by any chance you have not done packet 2, do it now before I do the worksheet. You can always pause my video, have the worksheet up on your computer screen or iPad while you're watching the video on your computer. But always make sure you do the problem before I do. Pause the video and then let the video run to see the solution. Okay, so the first problem is domain. We haven't done this in a long time. So remember that domain means all the possible x values. And range means all the possible y values. Okay? And interval notation is the brackets and the parentheses, right? So that's, we have parentheses sometimes, we have brackets like this. Sometimes we have a parentheses and a bracket, or a bracket and parentheses. Remember that parentheses means does not include. Does not include. And bracket means it includes. Okay, so for example, if I put negative, well, let's go to this one, -1, 4, that means our solution, or in this case our domain, would start at -1, and it would go up to 4, but not including 4. So 3.999, but not including 4. Whereas the bracket means it would include -1, as well as -0.9, -0.8, etc. Okay, so let's look at our picture here. Okay, so for this problem here, we can see that the sideways parabola goes all the way to 1, right? This is 1, this is 2, 3, but it doesn't go past 1, but it does include 1. There's a point there, that's the vertex. So it includes 1. So again, x values. We're not worried about how high it goes. We're worried about left and right. That's the furthest left point there is, and we always write our interval notation for domain and range from left to right for domain and from bottom to top for range. Always lowest to highest numbers. So the lowest x value is 1. And this arrow means it goes on forever. So our highest value is infinity. Now, infinity is easy. Whether you have negative or positive infinity, it's always a parentheses, never a bracket. And in this case, 1 is included in the solution. So it's bracket. Okay, so that means start at 1, including 1, start at 1, and go forever to the right towards infinity, and the parentheses means because you can never reach infinity, so we always use parentheses for infinity. Now the range is how high it goes, right? So if we follow this line, it's going to keep going in this direction. It does slowly go up, but it goes up forever. And same thing here, it goes down forever. So even though it takes a long time, if you follow along this arc, it will eventually keep going down and down and down and down. So actually it reaches negative infinity and positive infinity. It takes the whole, all possible y values are true. Sometimes we call that all real numbers. So another way to write this is all real numbers is this, which means all real numbers. We don't usually do that in class. You could write that and get full credit. Although we did say interval notation, so we kind of are expecting this. So if it says interval notation, this is the right answer. But that is also correct, saying it's all real numbers. And every time we do a parabola, one of these, so a sideways parabola, this will always be all real numbers. And for a vertical parabola, the domain will be negative infinity to infinity. So that's a good thing to remember too. Okay, let's go to problem 6. So problem 6 is we're dividing a whole number or an integer by a fraction. So we know we have to, first thing is make that integer a fraction. Okay, so, and then we want to have fraction divided by fraction. We know how to do that. There's a special rule for that. But we can't do it when it's in this mixed fraction notation. So what we have to do is convert this to an improper. Now, a lot of you, by mistake, include the negative when we do this. You don't include the negative. I mean, the answer will be negative. The fraction will be negative. That's all you do. But you don't include it in the work we do to convert this to an improper fraction. So you just take 1, positive 1, times 4 is 4. Plus 1 is 5, and we leave the denominator alone. What a lot of students do by mistake is they multiply -1 by 4 and say -4, then they add 1 and they get -3, and that's going to give you completely the wrong answer. So you just take this negative sign, you move it to the answer, and then you ignore it completely. So you treat the problem as if it was 1 1/4, which converts to 5/4. Okay, and then to divide two fractions, of course, we do keep, change, that's multiplication. You can put a dot if you wanted to instead, and then flip, right? And we want to keep the sign here, even though you can kind of just know the answer is going to be negative, because it's a positive number divided by a negative number has to equal a negative number. So you got to do that first. So, and then we just multiply across. So 4 times 4 is 16. 1 times 5 is 5. And that's the final answer. You want to put it down here, that's fine. Okay, problem 7. Match each graph to the shape, right? So the main thing we want to look for is the highest power. This is second power, or quadratic, and this is cubic. And this is a linear function, right? We know y equals mx plus b. So the obvious line is here. Okay, so we know this is the line, and that only leaves two other ones. And then we know parabolas, we've done these in class, but it's basically the number of wiggles, right? So this only has one turn, this has two turns, right? So this is a quadratic, and this is a cubic. The more complicated those turns get, the higher this power. So this is a parabola, and we want to put the whole function here, and then this is a cubic function. But you should be familiar with parabolas. We've done enough of these with the squared. We did a lot of plotting points and then seeing what the shape looked like in class, so we should know what a quadratic looks like. You may not know what a cubic looks like, but it's process of elimination. If you know this is linear and quadratic, then this has to be the other one. Okay, problem 8. Make up x value. This is exactly what we talked about a minute ago. So make up x values, find the y values, plot the points, and draw the shape for the function. So normally, we always try to use -2, -1, 0, 1, 2, and then we find the y values. There are some exceptions, like if this was a fraction, we would want to make things divisible by that fraction. So if this was like x over third, or x squared over third, we'd want to use things that, well, if it was x over 3, which we've done before, you want to use things that are divisible by 3. So you can just try these numbers like we always do, and if you get some good answers, that's great. If you get answers that are off the screen, or off the graph, then you just try some other ones. You can always add them down here. So you could add, for example, -3 down here. You could add 3. You could put a fraction if you needed to. But we'll always start with these 5 generally when we're exploring. Okay, and we're going to use parentheses. So it's going to be y equals, and we'll just erase every time we do this. We don't have to be fancy about this and show all the work, right? Although it's not hard to do, so you certainly could. And maybe it's a good idea for practice purposes to put them all in here. So we're going to put -2 in for x, then we're going to try -1, then we're going to try 0. We can kind of do without doing any of the work, right? And then we'll do 1 and 2. And don't forget your negative sign up front here. The x gets replaced with a parentheses. We talked about this in the other video. So all of these are going to look the same. And then I plug in my various x values that we're testing here. And we'll talk about 0 in a second. Okay, so -2, PEMDAS says to do this first, right? I'll highlight it for you. So -2 squared is +4. That's the exponent phase. Then we're going to take +4 and multiply by -1. That's the multiplication phase. And you get -4. And -4 plus 4 is 0. So we're going to put a 0 here. Okay, same thing here. -1 squared is +1 times negative is -1. -1 plus 4 is 3. We can do 0 in our head because this whole term becomes 0. So that's 0 plus 4 is 4. And then 1 is going to yield the same result as -1 because 1 squared and -1 squared are the same exact answer. So that's why we know we're going to get 3 again, although you can work it out. And then 2 is the same as -2 here because it's going to be -2 squared is +4, 2 squared is +4. So I'm going to get a repeat there as well. Going to get 0. All right, let's plot these points. -2, 0. This is where a lot of you have a lot of problems, right? You always have to remember the x goes first. X is left and right. It's good to label your axes actually right away. If you want to put a couple of numbers here to help you, you don't have to put all of them. Put some random ones so you know of course, that y is positive here and negative down here, x is positive here and negative down here. So this is where a lot of you have the problem, is actually plotting the points. So negative 2, 0, negative 1, 3. Okay, I'm going to use different colors so we don't get too confused. Okay, so negative 1, 3 is actually right where I put the number 3. 0, 4, so 0, 4, that's the y-intercept. And then 1, 3, and 2, 0. And if you can kind of see that's going to make a nice parabola shape. So be careful. Make sure you don't go vertical here. It does curve in, but it shouldn't be vertical. I kind of missed on that one. So it'll be perfect, but okay. And show work below. I just did all the work here. It's fine. There's plenty of white space. You could have done the work up there, but you do need to show some work here. So let's see. We made up x values. We then found all the y values. Then we had plotted the points, and then we draw the shape. So we're pretty much done here. If you want to do domain and range, we can do domain and range really quick, because just add to that question. So pause the video right now. Try to figure out the domain and range in interval notation. Look back in the video earlier if you want to, and then come back to the section and then see if you get it right. Okay, so the domain is all real numbers, or negative infinity, comma, infinity. Don't forget the parentheses, because it goes left and right everywhere. And then the range has a low value of negative infinity. Okay, so in other words, it goes forever in this direction. So it's going towards negative infinity, but then it comes up, 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 and up, and up, and it gets as high as the number 4, but never higher than 4. And it includes 4 because that's the vertex. We actually had a y value of 4 right here, and that's the highest number of all these numbers you can see. That's why it's a maximum, and we know that it stops at 4. That's the highest number. So hopefully you got that right, even though it wasn't part of the original homework. Oh, there is domain and range. Okay, so it wasn't asked in the question up here. It should have been. Instead, they just put in the answer slot. So domain and range were included. So hopefully you did that. Okay, divide and put the answer in simplest fraction form. So we're going to divide, and then we have to subtract. They didn't really mention the subtraction part here, right? So it's going to be 1 minus something. So we're going to do what we call chunking. We're going to just do this piece over here, and we'll worry about the rest of the problem later. So let's just deal with these two pieces. So it's 2/3 divided by, and again, make this an improper fraction. We talked about how to do it. Ignore this. 1 times 3 is 3. 3 plus 1 is 4. And then don't forget the negative now that we're done with the problem, right? All right, that's keep, change, flip. So that's equal to 2/3 times, I'll use a dot this time, a little less confusing, negative, sorry, I forgot the flip, right? Negative 3/4. Okay, so keep, change, flip. Make sure I did that in the other part. If I did that wrong in the other problem, you know that I did it wrong. You can fix it yourself, okay? 2 times negative 3 is negative 6. Well, it's negative. We don't have to put the negative 6 here, so let's start again. So we just know positive times negative is negative. So we're just going to put a big negative in front of our fraction symbol there, okay? And then it's 2 times 3 is 6, and 3 times 4 is 12. And that works, that simplifies, of course. We always want to simplify fractions to negative 1/2, which makes our life easy. So we're going to take this answer here, and we're going to put it back in the original problem, right? So the original problem here that we kind of skipped over was 1 minus this number, right? And I'm going to put it in parentheses just because it will show you something. So it's 1 minus negative 1/2, but negative times negative is positive, or when you subtract a negative, or I subtract debt, that's a positive thing. So it's really 1 plus 1/2. And of course, that's 1.5 or 3/2. We usually like to leave things in improper fractions, but 1.5 would have been acceptable too, particularly that they gave us the problem in a mixed fraction. Okay, number 10. You and 2 friends go out to eat. The bill comes to $120 before the tip. That's always good to underline important parts of the sentence that you don't want to forget, right? And then we're going to add a tip of 15%. How much should each of you pay to split the bill? So the first thing to remember is there's you and 2 friends, right? So that's 3 people. A lot of people tend to think it's only 2 people. It's you and 2 friends go out to eat. So that's 3 people. Okay, so the bill comes to $120. And then we're going to add the tip. So the tip is 15% of $120. To multiply by percent, you change the percent to a decimal. Okay, and then you multiply, so 0, 0, 10, 6, and then 0, 2, 1, and it's 1800, but there's 2 decimal places, so it's $18, and that feels right. You should know what 15% feels like, right? 15% feels like a small part of this number. It wouldn't be like half. It wouldn't be 60. It wouldn't be 240, right? So a big part of math, and you've probably seen me make a mistake before, but the big difference is I kind of know when a number is way off. I know that the tip shouldn't be $100 if my bill is $120. Okay? So the final bill, including the tip, right, of course, is $138. And you want to split it 3 ways because there's 3 people. So we're going to divide it by 3. Okay, 3 goes into 13 4 times with a remainder of 1. 18, 3 goes in 6. 6 times 3 is 18. So it goes in nicely. So basically, everybody's going to pay $46. Okay, another good thing to check is make sure, this rounds up to about 50, roughly $50. It's very close to $50. So you say to yourself, if 3 people are going to pay $50, it's $150. That makes sense, right? Because it's got to be this or higher, of course. So if you get something like 10 or 20, then you know you did something seriously wrong because you didn't even add up to the original bill. Okay, do all the shown operations, then simplify the answer. So this is multiplication. Here's a big, big mistake that everybody makes. I'll do it in red to show that it's a mistake. A lot of people go, oh, 2 times 5x, and then they do 2 times 5x, and you get 10x times 10x, right? But if you think about just multiplying 3 numbers together, right? This is 6 times 4 is 24, of course, right? So watch, you could do 6 times 4 is 24, or you could do 4 times 3 is 12, times 2 is 24. You could do, because the order doesn't matter, 2 times 4 is 8, 8 times 3 is 24. But notice there's no distributive going on here, right? There's no distributive property like there's going to be here. There's no distributive property because it's just 3 things multiplied together with they're all monomials, right? There's no binomials. So it's not like 2 times 3 minus 4, right? Of course, we would just put -1 here, but again, if this was x minus 4 or something, right? Now you're multiplying a monomial times a binomial, and that has to be used distributive property. But this is not distributive property. You just always, when we're first learning this, we often always mistake. We see a number, our brains are telling us there's a pattern going on here. It's a number times a parentheses. Whenever I see a number times parentheses, my brain says, distribute, don't forget to distribute, distributive property. But that's not the case all the time, of course. It has to be a monomial times a binomial. Okay? Just because there's a number next to parentheses does not automatically mean distributive property, so be careful. It's just a monomial times a monomial times a monomial. So it's 2 times 5 is 10x, and 10x times 5x is 50x squared, right? 10 times 5 is 50, x times x is x squared. I'm going to switch to my smaller pen here. Okay? And then this one is distributive property. So 2 times 5 is minus 10. -2 times -x is plus 2x. Big difference here because this is a monomial times a binomial. So I have to distribute. There's a negative sign here. That let me know it's a binomial, plus or minus here. That means I have to distribute. Big difference from this. That's why we gave you this problem, so you could contrast the 2 different multiplications happening here by 2, and you can see the big difference here. This is also distributive property. Even though there's nothing written here, we know by default there's really a hidden 1 here. So it's -1 times 1 is -1, and -1 times -x is plus x. Okay? And then that's multiplication, right? So we just finished multiplying, right? With multiplying, it doesn't matter if we have different bases or different... it doesn't matter whether we have like a number times x, right, or x times x, because it's multiplication. But now we're going to do addition and subtraction. So now like terms matter, right? The power has to be exactly the same. So you can see there's no other 50x squared term. In fact, you can take your highlighter and do this, or you can do triangles and squares around them. We've talked about this. So that is different from this. And of course, these two don't have any variables. See, so the like terms are the purple and the blue are like terms. I mean, to each other. The purple to each other and the blues to each other. So this guy, nothing can be done. So we're going to just leave him as 50. Just change my pen here. 50x squared. Nothing can be done. Negative 10 minus 1. Well, we like to put things in standard form. So standard form, if you remember, has the highest power, then the second highest power, then the lowest power, right? So in this case. So 2x plus x is 3x, and then we'll put the number last. So we like to have descending order of powers. See, x squared, x to the first, and then x to the 0, or no x. And then minus 10 minus 1 is minus 11. Okay, you don't have to copy it here if you circle it, but I will. All right, so really careful in number 11. Make sure you listen to all the tips that I gave you. And okay, so this is a function. This is actually called a piecewise function. We haven't talked about that in the name of it, so we don't really test you on that. But when we get to Algebra 2, this is called a piecewise function. It's really like made up of a parabola for a little while, then a horizontal line, then a diagonal line. So it's made up of 3 different functions. And depending upon what your x value is, you act differently to each function, or you treat which function is active depending upon where you are in the x-axis. For our exercise, it doesn't matter to know that. All this says is f of negative 1. That's what is the f value, what is the y value when x is negative 1. So we go to negative 1 right here, and we say, where along this dotted line do we hit the function, right? What is the y value, or really the f value? What is the f value along this dotted line? And it's right there, right? That's the only point on our function. And if you look at the y value, it's 1. Okay, f of 0. So that means where is x equal to 0? Well, x is equal to 0 here, 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 all of these millions of places. X is equal to 0, but this is where the function hits. So f is equal to 0 when x is 0 because it goes through the origin. F of 1, so again, where x is 1, we look up to the graph. It could be here or here, but this is an open circle, which means it doesn't include. This means a solid circle, so it does include. So the answer is 1, right? And when x is 1, right, that point is 1, 1. So when x, just to highlight this for you, when that, too big. When x is 1, that's this, right? What is f, right? What is f? And f is 1. It's right there. Okay? F of 1.1. Well, 1.1 is just a little past 1. So if you go a little past 1, like right about there, doesn't matter exactly where, you realize we're way up here. Anywhere between 1 and 2, not including 1, anywhere between 1 and 2, the y values are all the same. They're all equal to 3 because everywhere on this line, the y values are equal to 3. So the answer is 3. And finally, f of 3. So that's when x is 3. What is the y value? There it is. That's the point, because when x is 3, f, which is the number back here, is 3. Okay, now this is a similar problem we had before with fractions, but it's solving. So there's an equal sign here. When there's an equal sign here, I can do all kinds of neat tricks. Like, for example, I can multiply both sides by the common denominator because that will get rid of all my denominators. A lot of people had trouble with this last time we reviewed this, so we're going to be extra careful here. So I'm going to multiply both sides by 15 because there's a 3 and a 5, and their common denominator is 15. So and this is distributive property, unlike when we said before it wasn't, because there's a binomial here. These are both binomials. So 15 is going to be multiplied here and here. This 15 is going to be multiplied here and here. So 15 times x is 15x. 15 times negative x over 3 is negative 15x over 3. But the whole point of doing this is so that it will reduce. So 15 thirds reduces to 5 over 1. 5 over 1. So we're going to do that right away. We're going to bring down our equal sign. Then we're going to do this distributive property. So it's 15 over 5. And then 15 times negative 1 is negative 15. But we're going to reduce this fraction too. All your fractions should reduce because that's why we did it. So if we rewrite this entire equation again, we're going to get 15x minus 5x equals 3 minus 15. Now, you could have combined these two fractions to begin with and made your life easy too. That's fine. It will work that way. You can even combine these two and get a common denominator, and then you'll get 2 fraction equals a fraction, and you could just multiply both sides by the common denominator there. It doesn't matter as long as you're careful about that. I just like to avoid all that. I like to just get rid of the denominators as fast as possible. And the only thing you got to be careful about is that you reduce these fractions before you keep going. Okay, so 15x minus 5x is 10x. Those are like terms. We're in the addition phase, right? And 3 minus 15 is negative 12. And then what do? What's the inverse operation of multiplication? Because this is 10 times x. Oh, the inverse operation is divide by 10. Okay, and finally we get x by itself on the left side when I reduce these fractions. And then on this side we get negative 12 tenths, but that reduces to negative 6 fifths. So we want to make sure that that's our final answer. Okay, let's move on. Solve for s. So this is what we call a literal equation because it has multiple letters in it, right? It's a y, an s, and a w. So our answer is going to have an s, a y, and a w, right? So we need to isolate s. Now normally I would say multiply both sides by s, but I want to do that after I move this negative 2. So I'm going to do the inverse of subtracting 2, which is add 2. These are not like terms, so they're just stuck together with a plus sign. There's nothing you do. And of course I'm just bringing down the left side over here because this is 0. Now I have one denominator. Even though that's what I'm solving for, I still need to multiply by it to get it out of the denominator. Okay, so I'm going to multiply the left side by s over 1 and the right side by s. Okay, so I'm going to get 2y equals w plus 2 times s. Now, why didn't I distribute this, you ask, right? I could have distributed it, but then I'm going to get 2 s terms, and that's going to make it very, very difficult for me to get s by itself. So although you normally would distribute it, and you could distribute it here, you'd then have to factor it out again to get it by itself. So all I did is I just left it here because I know I want this alone. I don't want it mixed up with something else. And so now I say to myself, what do I need to get this by itself? Well, it's being multiplied by this. So I need to divide by that. Both sides. Looks very strange, but that's actually the final answer because anything divided by itself is equal to 1, and I'm left with s by itself, and then I just get 2y over w plus 2. Okay? A lot of people, I'll do this in red, try to do this. That's not true. You can't do that because this is not in factored form. It would have to all be multiplication and division. There wouldn't be allowed to have any addition mixed in there. So you can't do that. I can do it here because the whole thing, it shouldn't be red really, but I'm reducing the whole thing, the identical term. That's a lot different than trying to go into the middle of this thing here and taking just the 2 out and doing that. That is totally wrong and not allowed. So the final answer, believe it or not, is that. And we will use symmetric property of equality just because we love s or the variable on the left side. So I'm going to use that in my final answer. You know how to do that. And that's what I get. That's a not so easy problem. 4 pi minus pi. How many times have we done this? There's a 1 here. They are like terms. 4 apples minus 1 apple is 3 apples. It's always an easy problem on the exam. Try not to get it wrong. Solve for x. That is a typo, right? This is just simplify here. Or actually, it's, expand. And so the directions are wrong there. Should be simplify. That was a copy and paste from this problem here. So 1/4 times 1/4 squared. I like to always write it expanded. You certainly can use power rule that we talked about, or the exponent rule here, but it's really just anything times itself. Squared means multiply by itself, so it's 1/16. 4 times 4 is 16. 1 times 1 is 1. So these last two problems we did in about 3 seconds. Real easy. Okay, this is a pretty tough problem here. It didn't say any directions here, but I'm sure what they meant was simplify, so we're going to write that. Okay, and then we're going to first do the power before I do multiplication. So 3 in front of a parentheses means multiplication. The 2 over here means a power exponent. PEMDAS demands that we do E before we do MD and A and S, right? So we want to square this first. Actually, I'm wrong. We need to do P first, right? Because we wouldn't know how to square that anyway. That's our next unit. I want to do p first. So normally we often skip p, because if this was like x minus 1, there's really nothing you can do because they're not like terms, right? But in this case, this is doable, right? There is an answer to this that we can do. So we definitely don't want to square this first. We want to do p first. We want to do the first rule, p. So what we're going to do is add these or subtract them together. So we're going to first convert them to be 3 minus 5/3, right? I'm not going to go over how to do changing a mixed fraction to an improper fraction. You know how to do that, okay? And then I need a common denominator, so this is going to be times 3 on top and bottom. 9/3, just make sure that's equal to 3. It is. 9 divided by 3 is 3. Minus 5/3, so I just found a common denominator. And this is, of course, 4/3. So I'm going to replace all of this with 4/3, because that's what those two fractions are equal to. I'm going to put it over here, and I'll leave it in black, except for the part that I substitute, right? So that's the original problem, except where all that yellow was. I'm going to put 4/3, right? It's going to go in here. Okay? And then squaring comes first, then multiplying. So I did PEMDAS, I did P for PEMDAS. Now I'm going to do E. I'm going to square 4/3. What is 4/3 squared? Well, it's times itself, right? So that's 16/9. Numerator times numerator, denominator times denominator. So it's 3 times 16/9. That's what 4/3 squared is. Now I'm going to put 3 over 1 and multiply, so it's 3 times 16 and 1 times 9. Okay? I can reduce this beforehand if I want to, but in the end I'll just end up dividing by 3. So 3 times 16 is 30 plus 18, so 48. And then 1 times 9 is 9. But this does reduce because 3 goes into both of these. 3 goes in 16 times, 3 goes in 3 times. So you get 16/3. Okay, given the equation c of t equals t over 2 minus 6, this is linear, by the way, in case you haven't noticed it. It's a line, right? Y equals, and m is 1/2, right? Y equals mx plus b, and plus the b is negative 6, in case you didn't notice. Given the equation where c is the temperature Celsius and t is the time, at what hour, right? So what they're really asking for is t. When they say at what hour, they're saying what is t. And the temperature 2 degrees Celsius, this must be c, right? That's c. So basically, I replaced this c with 2. I leave the equation over here because we're going to solve for t, all right? Now to solve for t, we're going to multiply both sides by 2. I'm actually going to go pretty quick here because it's something we do a lot. You can use parentheses and write a 2 outside the parentheses. Distribute on this side if you want. But regardless, when I multiply everything by 2, everything doubles. This is going to be 4. This is going to be t because I'm multiplying by 2 so that the 2's will reduce. And this will be minus 12. Okay? And remember, I'm solving for t, so I'm going to add 12 to both sides. And I'm going to use symmetric property of equality, move t to the left, and I'm going to have t equals 16. (19) is find the intersection point, use substitution method, okay? Well, if we're going to use substitution method, we kind of almost have y by itself here, but I need to get y by itself. So I'm going to add y to both sides, which yields this. If I add y to both sides, this one gets goes away because it's minus y plus y, and then you get a plus y over here. So add y to both sides. Add 8 to both sides, and I get y equals, I'm going to use symmetric property of equality to move everything to the other sides, 4x plus 8. So that purple, right, is going to go in wherever there's a y in this equation. So there's the y. So this work that I just did is going to go right in here, right? So I'm going to get 2 times y. That's what I'm doing. I'm just copying this down. So 2 times y. And y, of course, we know over here is 4x plus 8. So 2y equals negative 2x minus 4. So all I did was substitute in for this y, what we got y to be when we isolated y over here. All right, distributive property, don't forget, because there's a plus sign here, so that's 8x plus 16 equals minus 2x minus 4. I'm going to add 2x to both sides, and I get 10x plus 16 equals negative 4. I'm going to subtract 16 from both sides, and I'm going to get 10x equals negative 20. And then I'm going to divide both sides by 10. X equals negative 2. Final answer. Actually, it's not the final answer. I'm sorry. They want to know what the intersection is. So the intersection is a point. So I need an x and y value, right? So my answer is going to be down here with an x and y value. I know that the x is negative 2. And I can just plug negative 2 in either equation for x. So I'm going to plug it in here. So I'm going to get 2y equals negative 2 times negative 2, which is what we had for x, minus 4. Okay, so 2y equals positive 4 minus 4, which is 0. So 2y equals 0. Divide both sides by 2. And I get y equals 0 over 2, which is 0. So that's the intersection point. How could I check this? Go to Desmos, put both these equations in, and just go to the graph and see exactly where they meet. And you'll see they meet at negative 2, 0. That's graphing method, or with a calculator, or with a technology graphing method. So you can try it on your own to make sure you see that we have the right answer. Create 3 different lines that are perpendicular to the line y equals x. Well, the slope of y equals x, right? This is plus b, so there's a plus 0 here. The slope is the number in front of the x. So the number in front of this x is 1. So the slope is 1. So the slope of a perpendicular line will be negative 1. So all I need to do is write 3 lines here that have a slope of negative 1. Very easy. So y equals negative x minus 1, y equals negative x, y equals negative x plus 20, doesn't really matter, right? All of these lines have a negative 1 slope, which is the negative reciprocal of positive 1, so we know we're right. Solve for x here, common denominator is 18, so we're going to multiply both sides by 18 to help us eliminate the fractions. 18 times 5 is 90. 18 times negative x over 3, so that's negative 18 over 3. And this is 18 times 6. 18 over 1 times 1 over 6 is 18 over 6. Okay? So, I missed my x. Okay, I see what I did wrong, right? 18x over 3. 18x over 3. Sorry about that. Now we're going to reduce. 18 over 3 reduces to 6 over 1. 18 over 6. We're going to put, does not reduce. Does not reduce. Oh, no, it does reduce. Sorry, not by the number I was going to write. Sorry. So 3 goes in here 6 times, goes in here 1 time. So this reduces by 2, right? So 2 goes in 3 times and 2 goes in, oh, it does go by 3. I don't know what I was thinking. That's okay. You could do that, right? So I made a mistake here, which is a good lesson here. So I divided both sides, not both sides. I divided the top and bottom by 2 to do by reducing. And I was like, oh, I got 9 out of 3. And I'm like, wait a minute, 9 out of 3 reduces again. See, so this is a good lesson here. It's okay to not reduce all the way as long as you recognize that it can reduce further and you just write 3. Right? And of course, it's silly of me not to know that because I multiplied by the common denominator on purpose to get rid of all the fractions. So everything should reduce to a number over 1. That's the whole purpose of what I do. All right. So finally, I'm going to rewrite everything. So this is going to be, don't forget the x. The x is still here, right? So it's going to be 90 minus 6x, right? Because the 18 and the 3 reduced. And then over here, of course, I'm going to get 3 over 1, which is just 3. So I got rid of the fractions because I multiplied by the common denominator. So of course this has to reduce all the way down. That's the whole purpose of doing that. Okay, and then I'm going to add 6x to both sides. I just hate to have a negative x term. That makes this plus 3. Subtract 3 from both sides. So I get 6x equals negative 87. I'm not negative 87, I'm sorry, positive 87. I was just saying subtracting in my mind and I wrote it wrong. Okay, and then I'm going to divide both sides by 6 to get x by itself. That may be the only thing we can do. I'm going to try to divide it and you'll see probably not going to work. 6 goes into 8 one times. 1 times 6 is 2. 27, 6 does not go into 27, right? Evenly. So I'm going to leave it as 87 over 6. Even though I think they can reduce, it can reduce by 3. So let's put 3 in here. 3 goes into 8 2 times. 2 times 3 is 6. 27 goes in there 9 times. So 29, that's a tough one because it's a big number. Okay, so x equals 29 over 2 in improper fraction form. Can't really fit it over here because it's a fraction, so we're just going to go like that. Okay, how do I know I'm right? I could plug it back in here. So if I wanted to do a check, this is my check. I would do 5 minus, now this is difficult to do, it's 29 over 2. And you know I don't ever like slashes, but I'm just going to do it here. Equals 1/6, right? And if you divide these two, if you make this a common, if you make this over 1 and you do keep, change, flip, okay, I'm going to get 5. Keep, change, flip, this is really going to be multiplied by 1/3, so I'm going to get 29 over 6. And I got to get a common denominator here of 6, so that's going to make this 30 over 6. Minus 29 over 6 does in fact equal 1 over 6, right? If I put a 1 over 6 in place here. So I checked my answer and it worked out okay. So you get a weird fraction, you're like, wow, that doesn't seem right. But when I check it by plugging it back in, it turns out that it's correct. Okay, this is from Unit 1, I think, where you have to do substitution. You're going to replace every variable with a number. So I replace every variable with a parentheses or a bracket. So I look at the first symbol, there's the first symbol. I hit a letter, the minute I hit a letter, I replace it with 2 parentheses. The next symbol right after the letter doesn't go away. Then it's a 1, then it's a negative symbol, and then I hit a letter. Every time I hit a letter, I put a parentheses or a bracket. Why am I using a bracket? Because it's next to a parentheses and I want to be able to see the difference. Bring down the squared, plus parentheses. Now I see a variable, I'm going to use bracket, of course. Next symbol is minus symbol, next symbol is a variable, so I'm going to use bracket, close parentheses, and of course equals, where we're trying to evaluate what this is. So that's my first step, right? And then I take these numbers here, like -2 and 1, and I put them in for each letter. So x was -2, y was +1, right? Actually, I can't see here, so I'm trying to be careful. So y is +1. So wherever there's a y value, which is here, I'm going to put a +1, and here, which is +1. Okay, now we have to follow PEMDAS. So I have to evaluate this parentheses first, right? I mean, you can evaluate the inside of the brackets, but there's nothing you can do. So you're like, we can't reduce 1, we can't reduce -2. So inside these 3 brackets and this parentheses here, there's nothing to do. But inside, so nothing, can't simplify, can't simplify, can't simplify. But here, inside this parentheses, I can do that. And so also inside this parentheses, I can do that also. So I leave that alone because that's multiplication. We're not in that step yet. And then I take these parentheses here, I put the squared here, and I evaluate the inside. I'm doing P of PEMDAS, right? So I'm on, whoops, that did not supposed to happen. I think I hit my button here. Hold on 1 second. All right, let me just see if I can reset it here. Yeah, there we go. PEMDAS. So I'm on P, And 1 minus 1 is 0. And then 1 minus negative 2, I forgot to bring down the rest of these symbols here, right? 1 minus negative 2 is negative. 1 minus negative 2. Negative and negative make positive, so it's 1 plus 2 is 3. Okay, 1 minus negative 2, so it's 1 plus 2 is 3. So I did my P. Now I do my E, right? So 0 squared is 0. So this is minus negative 2 times 0 plus 3. So I did my E. M and D, negative 1 times negative 2 times 0 is 0. No multiplication over here, though I do drop the parentheses during multiplication division. Addition and subtraction, 0 plus 3 is 3. Okay, and that's our final answer there. So I hope this video was helpful. Learn from my mistake that I made over here. Remember my mistake here. Make sure you double check my previous answer over here. I did do, yep, keep change flip. We did that over here. So hope that was helpful to you. I'll be here available after school both Tuesday and Wednesday. Both days I'll be after school for at least an hour and a half. So please join us and work on some problems. Remember always to pause the video. Oh, I skipped 1 and 2, didn't I? Okay, so we'll go back and do those. So I'm not saying goodbye just yet. The intersection points of the lines 2x minus 5 equals 5, and these two use elimination method only. Okay. So I'm going to rewrite this. 2x minus y equals 5. And then I'll make this one blue here, and I'll put them underneath. So I want to make sure, first of all, that my letters line up. If they don't, we want to add y to both sides or subtract x or whatever. So I want to make sure, first of all, that everything lines up, the numbers on the right side. Another thing I might want to do immediately is convert this to improper, right? I never want to have a mixed fraction in the middle of a problem. Although in this case, actually, it would be probably easier, but I would still normally do it by default. 8, 9 over 2. In this case, because it's 4.5, it's very easy to add or subtract 4.5. So this might actually make a little more work for you, but it's usually a good habit to do. So I'm going to do it and say I didn't realize it'd be easier the other way to show you it doesn't matter. Okay, I lined them up, but I didn't change anything, right? I lined them up. So if I was to add these two right now, I would get 3x minus 2y, and I'd get some number here. Not going to help me because I still have variables. Elimination means I have to get rid of a number. So we look for two things that are the same coefficient, and we want their signs to be different. See here, I'd have to multiply by negative 2 along the bottom to make this eliminate. But here, all I have to do is change the signs or multiply both sides by negative 1. And multiplying by negative 1 is very easy. You can show the work. So you can put the parentheses here, put negative 1. You could divide by negative 1 too, by the way, which is not a great idea. But I can also just remember that when I multiply both sides of an equation by negative 1, it just changes all the signs. So I can just make it sign change, sign change, sign change. Okay? So I wrote the original equation. I wrote the second equation, making sure everything lined up vertically. I then changed the second equation by multiplying both sides by something, in this case negative 1. I change it so that one of the variables has the exact coefficient but different sign. So negative 1 and positive 1. So then once I do that, I add the two. I say I'm going to add this and this. So 2x plus a negative x, right, is equal to x, because it's like adding a negative is subtracting. So 2x minus x is x. Minus y plus y is 0. You don't have to write the plus 0, but just so you know it didn't go away. And I'm going to add these two, so it's 5 plus negative 9 over 2. So I have to change it to be a common denominator. So I'm going to make it to be 10 over 2. And I'm going to add that to negative 9 over 2. And I'm going to get 1/2, right? So you can see earlier it would have been easy to put 5 minus 4.5 is a half. So the improper actually made my life a little bit more difficult, but not ridiculously difficult. And basically we're done with the x value, right? So x equals 1/2. But we need a point. Look at it's bolded. A point always has what? It has an x and y with a parentheses around it. We're looking for an intersection point. So I need to plug this back into the original equation. Believe it or not, I'm going to plug it into the purple one because 2 times a half is going to make my life very easy. It avoids the fractions. So I'm going to take the original. You could do it to the blue one too, but I'm not going to do that. I'm going to take the original purple equation, and I'm going to put a parentheses where x is because I'm about to plug that in, and I'm going to solve for y. I could, as I said, plug it into the blue equation. It would work just fine. But this is going to work out nice because 2 times 1/2 is such an easy result, right? 2 times 1/2 is 1 minus y equals 5. I'm going to subtract 1 from both sides. Excuse me, this equals 4, right? Subtract 1 is 4. And then I've got to multiply both sides by -1 or divide by -1. I know you're thinking your instinct is to divide. That's the inverse operation of multiplying. But we always know that with negatives, you can just multiply by -1 and get the same result. So I'm just going to change the signs on both sides, basically. That's a quick way to do it. But if you show the work here and do -1 on both sides, multiply by -1, you'll get this. So I know that y value is -4, and of course the x value from before is 1/2. How could I check my answer here, right? How could I check my answer? Go to Desmos, put this equation and this equation exactly like you see it. 4.5 I would use here, but otherwise put that exactly in Desmos, put them both in, go to the graph, and look to see if it's 1/2 -4. I'm sure it is. But of course, as I said, sometimes I make a mistake, so it's always good to check me too. All right, number 2, create an inequality from a number is between -1 and 2 exclusively. Exclusive means we don't include you. If we exclude you from the group, that means you're not part of the group. Unfortunately, that's not a nice thing, but that's how it works, right? Exclusively. So not including -1 and 2. They're not allowed. So we want to say from -1 to 2, right? Start with an inequality, sorry. So a number is between. A number is x, of course. A number is between. So we want to put x between. So it's greater than -1 and it's less than 2, right? We always want the lower number here and the higher number on the right side. And it's not this, or let me use red, right? So, and I'll undo it in 2 seconds. It's not that, because that would include -1 and 2. We want it to not include it. So when we go like this, that means it's less than 2, like 1.9999, and it's greater than -1, so like -0.99, but not including -1 and 2. So it's between -1 and 2, but not excluding -1 and 2. Find the slope of a line parallel to x equals -3. Well, x equals -3, as we know, and you have to memorize this. We've done it so many times. It's a vertical line passing through -3. Okay? And you want the slope of a line that's parallel to this line passing through the point -1,3, right? -1,3 is up here, but who cares? Because they just want to know what the slope is. They don't want the equation of the line. So if you're looking for the equation of a line, the answer would be x equals -1. That would have been the answer. But they said find the slope of a line parallel. Well, parallel lines have the same slope, and the slope of x equals -3, which is a vertical line, is undefined. So guess what? The slope of your line is also undefined. They did not ask for the equation of the line, but the equation of the line would have been x equals -1. That's the equation of a line that is parallel to x equals -3. They didn't ask that. Not that it's wrong, but they didn't ask that. They just asked for the slope. All vertical lines have an undefined slope. Okay, number 4, we've done a problem like this earlier. F of -1 given f of t is this. So in other words, when t is -1, so we put a -1 where t is. Everywhere that t is, we put a -1. So the f value when x is -1, or sorry, when t is -1, is 5 minus -2, right? Minus 2 times, 5 minus 2, -1. So -2 times -1 is +2. Multiplication goes first. And then the final answer is 7, right? So f of -1 is equal to 7. Okay, sorry about doing those last. Shouldn't have mattered. Still got all the solutions there. Good luck. See you in extra help, guys.